You're good with hypothesis testing for proportion and percent, I assume, because you haven't contacted me, so I'm hoping that's a good assumption. If you are having trouble, then email me. What we're going to do in this video is talk about testing hypotheses about mean. Now, the process is exactly the same. You're going to do the same first 6 steps that you've been doing on hypothesis testing. The only real difference is you're going to go to a different test on the calculator. You're not going to choose one prop z-test because you're not testing proportion, okay? You're going to either use t-test or z-test. So other than that, it's exactly the same process. You're going to compare your probability to an alpha. You're going to reject the null or fail to reject the null. Then you're going to use that same flow chart on page 366 that you did for proportion. So this should be super easy. Okay, so let's go kind of pull the PowerPoint up, talk our way through it, and then let you go work some problems and see how you do, which I'm sure is going to be great. So we're testing hypotheses about mean. Now, these first 6 steps are the same thing I've done before, but I do want to just reevaluate them, make sure they're okay for you, kind of review them very quickly. You're going to find where it says test the claim that and underline it in your word problem, just like you did on proportion problems. Test the claim that. So what you underline is what you change from an English sentence to a mathematical sentence. And then you put the word claim next to it in a parenthesis. Then you have to write a second mathematical sentence that encompasses all the other possibilities, just like you did before, okay? Now, one of those is your null hypothesis and one's your alternative. All right, try to remember, how do you know which one's which? That's right, the null hypothesis is the one that has equals in it, okay? And then by default, the other one's your alternative. Now, the alternative tells you which test to use. So remember, if it's less than, use the left tail test. The way I remembered it was, it looked to me like it was pointing to the left. When it says right than, when it says greater than, you're going to do a right tail test. And to me, it looked like it was pointing to the right. And then not equal to in your alternative is a two-tail test. So remember, you're always testing the null hypothesis, okay? And then the alternative hypothesis tells you which test to use. Find your significance level. It'll usually just say in the word problem, and that's your alpha. If it doesn't say, the most common, usually by default, is decimal 0.5. Now, here's the part that's a little different. Step 7, about your calculator. You're still going to go to the calculator and look for a probability. You're still going to go down, you're going to go to stats on your machine, then you're going to go over to test, and you're going to scroll down, but you're not looking for one prop z-test. You're either going to pick T as in toy test or Z as in zebra. So t-test or z-test. They're the first 2 ones on my machine. I'm not quite sure about yours, probably similar. Now, how do you decide whether to pick a z-test or a t-test? It all depends on the standard deviation that they gave you in the word problem. If they've given you the standard deviation for the whole population, which is sigma, you use a z-test. If they give you the standard deviation of a sample, which is S, you're going to use a t-test. And most of the time, you're going to know S, so most of the time, you're going to pick a t-test. But occasionally, you might pick a z-test, so I wanted to make sure that you knew that was a possibility. So once you pick that t-test, it's got data and stats. You're going to go over to stats, and you're going to enter the following values. It's going to ask you for mu sub 0. Now, just like p sub 0 came from your null, mu sub 0 comes from your null. So whatever number's in the null goes there. Remember, X bar stands for the mean of a sample. So either they give it to you in the word problem or you can find it yourself. You know how to get the mean? You add the numbers up, divide by how many they are. So the mean of the sample goes here. Now remember, S is the standard deviation of the sample. Now, this is a TI notation that I'm not a big fan of, but I didn't create the machine, so I don't get to pick. S is the standard deviation symbol. But TI right here uses SX. I think the standard deviation of their X values is kind of their thought process. But this is where you put your standard deviation, then of course ends your total. Then you have to decide whether to use not equal, less than, or greater than. That comes from your null hypothesis. Enter all that in your machines and hit calculate. And you're going to be looking for the probability. So you're looking for P on your machines. And then you're going to do the same thing you've done the whole time with hypothesis testing. You're going to compare your P to your alpha. Remember, if P is less than or equal to alpha, you're going to reject the null. If P is greater than alpha, you fail to reject the null. So actually write that phrase on your paper, then go to page 366 in your books and follow that flow chart and write me your answer. Remember, your answer is an English sentence. So let's go do a couple real quick. Look at this first example. A study of body temperatures of healthy adults, 98 healthy adults, found the average body temperature to be 98 and 31/100 degrees Fahrenheit, with a standard deviation of 61/100 of a degree Fahrenheit. So use the decimal 0.5 significance level to test the claim that the average body temperature of a healthy adult is 98 6/10 degrees Fahrenheit. Now that's a commonly held belief. You know, when you check to see if you have a fever, usually you think that if your normal body temperature is 98.6. So we're trying to find out if that's accurate or not accurate. So we find where it says test the claim that, and then we underline it. That underlined thing is what I turn into a mathematical sentence. So average, remember that's mean, so it's got two symbols, mu and x bar. Now, why did I pick mu? Because remember, with hypothesis testing, you need population symbols. So mu is, so that's equals 98 6/10. And I wrote the word claim next to it so I don't get lost when I go to the flow chart later. Now, if that's not true, if it's not true that mean equals, then the only other alternative is the mu does not equal. So that's where I got those two. Then you have to decide which one's the null and which one's the alternative. Now remember, null hypothesis has equals in it. All right. And so that's why that one got labeled the null hypothesis. So by default, the one that was left had to be the alternative. Now remember, the alternative tells me which test to use. So it has not equal, so that's why I picked the two-tailed test. My significance level in the word problem, they told me to use 0.05. Now I've got to decide which test to use. Well, I go back up here. They told me the standard deviation was 0.61, but it doesn't say S or sigma. Why did I decide it was S? Because this was the standard deviation for these 98 people, which came from a sample of a study. So if a value comes from a sample or a study, it's got to be S, not sigma, okay? So that's how I knew to choose t-test. Then remember, this mu sub 0 comes from your null hypothesis. They told me the mean and the standard deviation in my problem, and they told me there were 98 people for my total. My alternative had not equal to, so I choose not equal to, and I hit calculate. And I'm looking for my p-value. Now, when I looked on my calculator, it had p equals 8 point something, and I panicked for a second. Because remember, probabilities are between 0 and 1. Probability can't be 8 point something. But when I kept looking out, oh, there's an e negative 6 out there. So remember, read all the way to the end on these numbers on your machines. So that meant that the decimal was really 6 places to the left. So that's why there's 5 zeros before the 8. And then I just rounded to the 4. So I'm going to compare that probability to my alpha. And obviously this number is much smaller than that one, so I rejected the null. All right, then I go to that flow chart on page 366, and it says, does the original claim contain the condition of equality? Well, see, there's my claim. Yes, it does. So I went to the right. Do you reject the null? Yes, I did reject the null. So I literally wrote down, there is sufficient evidence to warrant rejection of the claim that. And then when I got to the that and the dot, 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 I went back and wrote in what I had underlined in my original problem. The average body temperature of a healthy adult is 98 6 degrees Fahrenheit. So it looks like that's not an accurate statement, okay? So basically, we'll talk about this more in a minute probably, but what you're really doing when you reject the null, the reason this alpha is a 0.05, that's a percentage. Remember, the definition of unusual was less than a 5% chance. So what we're saying is, if this statement is true, if the average body temperature really is 98 6/10 degrees Fahrenheit, then me getting 98.31 degrees Fahrenheit in my study of healthy adults, this was the probability that I would get that data if this statement's accurate. So that's a tiny probability. So what I'm really saying is, if there's a less than a 5% chance that this would happen if that was true, then I make the assumption, well, that's not true. And that's why the null gets rejected. All right, let's go look at another one where you have to do just a little more work, and that's this. A study found the following pulse rate for adult female subjects to be, and so one person had a resting pulse rate of 72 beats per minute, and another woman had a rate of 69 beats per minute. You know how when you test your pulse rates? okay? So it said this time use the 0.01 significance level to test the claim that the mean pulse rate of adult females is less than 75 beats per minute. So remember what I did, I found where it said test the claim that, and I underlined what followed. So this is what gets changed to a sentence. So remember mean, that's your average, either mu or x bar, but I've got to use the population symbol mu, and then it says less than, so there's my less than 75. So that English phrase got changed to mathematical sentence. I wrote the word claim next to it. Now, if it's not true, if mu really isn't less than 75, well, what must be true? It's either got to be greater than or equal to 75. So that's my second statement. Then I had to decide which one was the null. Remember, that's the one with the equal. So this one's got the equal, so is this the null? So by default, that one's the alternative. And the alternative tells you which test to run. So it's a left tail test because I've got less than. Okay, and then my significance level was 0.01 this time. Now here's my problem. I don't know if I have S or sigma. It didn't tell me my mean or my standard deviation up here. So I entered all of these values into my machine in the list. Then I went back to stat, went over to calc for calculate, and did one variable statistics. And I found out that if you add these 16 numbers up and divide by 16, that's your average. So that's the sample mean. And this, I got the standard deviation from the calculator, but you could do it by hand with a formula, okay? But the reason I know it's S is, again, it came from this study of these female pulse rates. So when some data and standard deviation comes from a sample or a study, it's S, not sigma. And then my sample, I counted up, there were 16 numbers, so my N must have been 16. Again, I looked at that alternative with less than, and I choose the less than and hit calculate. And this came out to be my probability. And again, I compared the probability to my alpha. I always put the P first and then the alpha. Remember, you find the first place they're different, so that 2 is obviously bigger than that 0. So this number is bigger than that number. When P is greater than alpha, you failed to reject the null. So then I went to my flow chart. Now look what your flow chart says. Does the original claim contain equality? So does it? See, no. So this time I went left on the flow chart to no. Did you reject the null? No. I failed to reject it. No. So I literally wrote down the words, there is not sufficient evidence to support the claim that, and then I wrote down what I underlined. The mean pulse rates of adult females is less than 75 beats per minute. So do you understand? This is telling you that if this statement is true, that there's about a 20% chance that you could have gotten this data. Now, to me, that's low, but it's not low enough to throw this out. Okay, so I would have to have, according to this, my significance level is 0.01, that's 1%. They did not want me to throw this statement out right here, okay? All right, they don't want me to throw this statement out unless this null, in other words, there's less than a 1% chance, so I can't throw this statement out, okay? So that's why I'm failing to reject the null. 20% is not less than 1%, okay? But from your standpoint, when your P is less than or equal to your alpha, you reject the null. When it's greater than alpha, you fail to reject the null. Okay, so simple. The only difference is you're going to go to a different place on your calculator. All right, Z-test or T-test, and I think most of the time it's T-test. If you have trouble, let me know.